Here is a demonstration of the LabVIEW library that enables communication with Fanuc robots. On the left, you can see RoboGuide, which simulates a robot, and on the right, a LabVIEW project consisting of a demonstration module and the library itself. This library contains multiple VIs that you can use, implementing various protocols. The library allows you to connect not only to a simulated robot in RoboGuide, but also to a real robot. In this demonstration, you can specify the IP address of the robot if you are working with a physical one. In my case, I am connected to the simulator, which is running on another machine. I can specify the robots folder, allowing the library to retrieve all necessary information about the robot. Next, I choose which protocol I want to use. In this case, I will enable all of them. I also verify that my license is valid. If it is not, you can request a trial license from the website under automation.com. Now I connect to my robot. The LEDs in the header indicate that all three protocols are successfully connected. I will start by introducing the Telnet protocol, which allows remote control of the robot, including executing a program. By default, if I attempt to run, for example, the Move1 program, I receive an error indicating that TP is enabled. To enable remote control, I need to disable the TP. Now I can launch my program. I can also pause it, display its progress to see which line it is currently executing, resume it, and check its execution status in real time. Additionally, I can retrieve the robot's current position, reset alarms, just like pressing the reset button, and access or modify variable values. For instance, I can set RMT master to 0 and verify the change. If RMT master is set to 0, remote program execution is disabled. It must be set to 1 to start a program remotely. Furthermore, I can read and modify port values. For example, I can switch do1 from on to off and do3 from off to on. Regarding inputs, if I attempt to set a port value, I receive an I/O point not simulated message. To simulate it, I use a specific command, simulate port with this value. Now, the input is simulated and set to on. I can toggle it to off and simulate multiple inputs as needed. Of course, I can also unsimulate them when necessary. Another useful protocol is FTP, which provides a wide range of information, including the robot's current position. If I move the robot and request the position again, I receive updated coordinates. Additionally, I can retrieve all input-output statuses, the error list, and the safety status. You can also access register values, including numerical, string, and position registers. Lastly, the SNPX protocol allows for fast data reading from the robot. Here, I can obtain the robot's current position at a high frequency, both in world coordinates and user frame coordinates. This protocol also enables quick reading and writing of all registers, whether they store numbers, strings, or position data, either in joint coordinates or Cartesian coordinates. Regarding the diagrams, the library provides specific blocks for connecting to Fanuc robots. In particular, the Connect to Robot block takes as input various robot-related details, such as its IP address or the path to RoboGuide, along with Boolean values to enable or disable specific protocols. Additionally, it requires connection credentials, including login and password. As output, this block generates an instance of each selected protocol, which can then be linked to other blocks as inputs. For example, to start a program, you would use the Run block, connect the Telnet instance, specify the name of the TP or Carol program to execute, and retrieve the success status as output. The library is available for a 30-day trial. It can be freely downloaded from GitHub. All relevant information and documentation can be found on underautomation.com.